Hi, I'm Dave Rayburn with Titon Energy along with Jake Eubank, one of our technicians here. One of the things we're going to show you today is we're going to do a little demonstration for you to show you how we do power factor correction on an AC inductive motor. Now the motor that we have here today is a 1/2 horsepower motor. It's running about a 6 amp motor?
Yeah, that's right.
Okay. Jake, you know, one of the things that's kind of frustrating is it seems like every time we talk to a customer or maybe an energy company, they always want to say, if your product really does what you say it'll do. Right. I'm sure you experience that.
Absolutely.
Or, you know, they look at it as if it's like this little magic black box or magic gray box.
Right.
And one of the things that we want to make clear today is that we're not doing anything out of the ordinary. We're simply doing power factor correction. Power factor correction is something that has been done for 80 to 100 years now, all the way back to, I guess, Tesla.
I believe that's right.
One of the things that we're going to do is we're going to show you what the amp draw is on this motor, what the power factor is on this motor, and I want you to keep in mind that this motor does not have a load on it. If the motor does not have a load on it, obviously the power factor is going to be much lower. Is that right?
That's correct. And we always want to try to size a motor, and we do this out in the field all the time. We always want to size a motor at its peak running load, what it normally runs at the peak there. If we don't do that, there is a danger of when it actually hits that peak running load that you might possibly overcorrect for the motor when it actually hits that.
Okay. And then what happens? That puts you into unity?
That's correct, and that can be damaging to some of the controls that might be in the system.
And that'll also cause harmonics.
That's right. That's
okay.
what might cause the damage.
Okay. All right. So one of the first things that we're going to show you, I guess what we want to do, Jake, is we want to run this first with no load and no power factor correction on it.
Right.
And one of the things we want to point out is these two wires, we've ran these off of each side of the phase of this single phase motor. This is just so that we can make a connection and hook the power factor correction up here, or the capacitance that is. So Jake, you want to go ahead and start the motor?
Sure. This has got a little plug-in meter on it, so this is the way you're going to be able to see the readings. Start it up. So you can see we're, just on a regular household outlet. It's 120 volts here, 60 hertz, like you saw just a second ago, and it's right now running on about 6 amps, like we were telling you. And the power factor is 21, or a 0.21.
Okay. Now what we're going to do is I'm going to just take these pliers and I'm going to put them up against the shaft on this motor. And what you're going to notice is the power factor is going to raise. Where are we at? 52, 60.
Hit about 60.
Hit about 60. Okay, so that'll give you an example, say in a manufacturing facility, to where a load will come up on a machine, puts the load on the motor, the power factor goes up high, then as soon as the load comes off, then the power factor goes back in the tank. So obviously our test kit's going to size it at that highest power factor load.
Every time.
Okay. All right, so now what we're going to do is we're going to show you, we're going to simply add capacitance to this motor. And this is the thing that we want you to understand. Yes, we use capacitance in our motor. We just do it differently. Okay, when we use capacitance in the motor, we're not using wiring. We're using it a much better capacitance in the motor. We're using, our box comes out to be a more efficient box and a faster way of manufacturing the box. We can actually manufacture a box with our new patented enclosure in less than a minute.
Absolutely.
Okay, so now what we've done, you may want to zoom in on this at the camera here. These are two, what are these, 80s?
Yeah.
Okay, these are simply two 80 microfarad capacitors. Okay, now we've taken the 2 microfarad capacitors, we've tied the capacitance together, which is making 160 microfarads. We've simply taken off of one side of the capacitors, hooked it to the side of the motor, and now Jake, go ahead and start the motor and we're going to show you what we've done Now again, we are not under any load. We're freewheeling on this motor. Okay, you want to raise that up a little bit higher?
Yeah. About like that. And still running at 120 volts, which is of course very common, and 60 hertz, which is of course what you'd get out of a normal wall socket. And still under no load, it's at 0.57 power factor.
0.57. Okay, now again, here we are in a manufacturing facility. Something runs into whatever that machine is, puts it under load.
It's 93.
93 power factor.
95.
What's the amp?
4.5.
Okay, so that took it down how many amps? 2 amps?
That's right. That's right.
Okay, so Jake, anything else that you want to add on this?
There's not much to it. It's pretty simple stuff. Not very mysterious at all. No magic beans or anything like that. It's just straight capacity.
Okay, so of course keep in mind again, this is only a 1/2 horsepower motor with 160 microfarads. This is what we want to make sure that everyone understands, is that again, we're not using some kind of magic. We are using capacitance in our box, but we're doing it again in a more efficient way